Hello and welcome everyone. In the previous tutorial, we have discussed the overall working of unsupervised machine learning, and now we will take a step further in this tutorial series, and here in this video we will understand different types of unsupervised machine learning. So basically the unsupervised machine learning is categorized into two major categories. These two categories includes clustering and association rule. Now we will start with clustering unsupervised learning, where we will discuss its working and categories in detail. Now, to understand the complete working of clustering analysis, we need to understand what is clustering. Basically, clustering is a technique of grouping together comparable groups of uncategorized data. This procedure makes sure that related data points are found and grouped together. Algorithms for clustering data are essential for processing it and identifying groups. In other words, the clusters are places with a high dimensionality of data points with comparable characteristics. It is typically used to analyze datasets, uncover meaningful facts among vast amount of data and form conclusions from it. The clusters typically have spherical shape. However, it is not always mandatory because they can have any other shape as well. Moreover, how the clusters are produced relies on the algorithm that we employ. There is no estimated standard for what forms an excellent clustering. So what we will do next, we will discuss the workflow of clustering. So here on the screen you can see the complete workflow. The process starts from data preparation. First, we need to prepare the data, where we must normalize, scale and manipulate feature data based upon main problem. However, we also need to make sure that the prepared data enables to precisely determine how similar the samples are in clustering. After data preparation, the next step is to establish a similarity matrix. So a clustering algorithm has to understand how similar pair of samples are in order to categorize data. By developing a similarity matrix, we can measure how similar two classes are, understand the data thoroughly, and how to infer similarities from the features. Now after this, the next step is to execute the clustering algorithm. So in this, the similarity measure is utilized by the clustering algorithm to group data. Now there are a variety of clustering algorithms that we are going to discuss further in this tutorial. So after executing clustering, the last step includes analyzing the findings and improve your clustering. So we need to validate the output of clustering and also evaluate the output's quality. At both cluster as well as example level, we will compare the output against predictions. Iteratively testing with the preceding procedures to observe how they impact clustering is necessary to improve the outcome. So I hope with this you got an overview of what is clustering and how it works. Let's move forward and let's discuss some of the key types of clustering algorithms. So very first type is centroid based clustering. Then there is density based clustering. After this there is distribution based clustering. This category also includes hierarchical clustering, fuzzy clustering, and in the last we have constraint based clustering. So let's start with the basic one, which is centroid based clustering. The centroid based clustering technique has a non-hierarchical structure that enables data analysts to specify data points into various clusters based on various characteristics and quantities. The centroid based clustering technique has a non-hierarchical structure that enables data analysts to specify data points into various clusters based upon various characteristics and quantities. So as the name implies, this clustering technique establishes a particular cluster around a centroid, or we can say the center point, that governs the distribution of data points. These algorithm always takes into account outliers, which are the data points that are far away from other data points. After this, the next type of clustering algorithm is density based clustering. In this, the algorithm groups together the data inputs with high density, and the data inputs are distributed to cluster according to their closeness to one another using the density based algorithm, which monitors the density of data inputs in a plot. Moreover, this density based algorithm is an effective form of clustering, and it distinguishes between data input and various densities. Now let's move forward and let's discuss the next type, which is distribution based clustering. So this type of algorithm, on the other hand, concentrate on classifying various data points according to the distribution that they came from, and it utilizes the Gaussian distribution to accomplish this task. Typically, in this, the plot's normal distribution sources determine how many clusters are created. Thus, this method ignores data points that appear to be far away from either of the sources. So this was all about distribution based clustering. Let's move forward and let's see an overview of hierarchical clustering. So the hierarchical clustering algorithm concentrates on building a hierarchy between all of the data points and then provide a mind map that shows the relationship between all the data inputs. For instance, taxonomies can be utilized to comprehend hierarchical clustering method, which enables us to discover hierarchy and the ensuring relationship among the diverse data points. So in this, each data point is initially handled as a distinct cluster, which is subsequently investigated with other data points. After this, different data points are created in the tree-like layout by joining data points based on hierarchies. So in this way, hierarchy clustering is being utilized. After this, the next type of clustering is fuzzy clustering, and this clustering technique is somewhat different from previous techniques of clustering. So in this, the algorithm builds data point clusters so that the single data point can be a member of multiple clusters. This algorithm is based on the idea of some data inputs can overlap in terms of feature. So it assigns a specific data input to multiple clusters based on the parameters of various clusters. So this technique is little different. What happens in this? Instead of categorizing a data point into a cluster, it categorizes a single data point into multiple clusters. So the next clustering algorithm is constraint based algorithm. Now, unlike rest of the algorithm that we have discussed so far, this constraint based algorithm is supervised algorithm. So previously we all discussed about unsupervised algorithm, but this constraint based algorithm is supervised in nature. It is a technique for building desirable clusters based on the size of quantity of elements. This clustering approach receives a training dataset which enables it to function on new data points, in contrast to other methods that are unsupervised in nature. As a result, whenever fresh data is fed into the system, groups of desired quantities are established, some of which may even be related to specific data points on the model using the constraint based method in data mining, and then the machine is given data to work with. So this was an overview of constraint based algorithm, and with this we have covered different categories of clustering. Let's move forward and let's discuss about the next category of unsupervised machine learning, that is association rule. Now this association rule is another category which looks for relationship between data items and maps them appropriately for increased profitability. This technique tries to look for relevant relationships or correlations between the dataset variables. At a very fundamental level, association rule utilizes machine learning models to examine dataset in search of pattern or co-occurrences. So it pinpoints the if-then patterns that are the association rules in and of themselves. So this association rule consists of two major components. Very first is this antecedent and the second one is consequent. An antecedent is something that can be located in the data, and an object that is discovered along with the antecedent is known as consequent. So these are the two main components of association rule. Let's move forward and let's discuss the different types of association rule. So the association rule is categorized into three major algorithms. First is a priori. So in order to generate association rules, a priori algorithms requires frequent dataset. It is made to function with datasets that consist transactions. To compute the item set effectively, this approach requires breadth first search and hash tree. So it is typically employed for market basket analysis, and it assists in discovering the products that are purchased in tandem. It can be applied to healthcare to help people learn about their diseases. After this, the next type of algorithm is ECLAT algorithm. This algorithm is a representation of equivalence class transformation. To find the frequently occurring items and in the dataset, this algorithm requires depth first search approach. So as compared to the a priori algorithm, this approach executes more quickly. And in the last, we have this FP growth algorithm. So here FP stands for frequent pattern. So It is an improvement of a priori algorithm which presents a tree-like structure that is known as frequent pattern or tree to explain the dataset, and it helps to identify most common patterns from the frequent tree. Now I hope you got an overview related to both of the categories of unsupervised machine learning. And with this, we have come to the end of this tutorial session where we have discussed about clustering and association rule. So thank you so much for watching. We will see you in the next one.